This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's problem is to find the smaller root of x squared minus 103x plus 2232 equals 0. The first method is to assume the roots are rational, simply because this is a puzzle given to us. The rational root theorem, which we discussed in our video of 4th of January, tells us in this particular case that any rational root must actually be an integer. This is because the leading coefficient here is a 1, and moreover, the product of the two roots must equal 2232. This latter fact we can also derive simply from the fact that if we factor our polynomial, it takes this form here, with lambda 1 and lambda 2 being the roots. If we expand out, we get x squared minus lambda 2x minus lambda 1x plus lambda 1 times lambda 2. And if we equate coefficients with this, we see that lambda 1, lambda 2 has to equal 2232. And moreover, we get a second equation that lambda 1 plus lambda 2 has to equal 103. So we're looking for two integers whose product is 2232 and whose sum is 103. For this particular case, because this number is relatively small compared to this number, I take the square root of this number here. The square root is approximately 47.2. And I'm therefore looking for two numbers either side of 47, whose sum is approximately 100. So I might first think of 4060, but 4060 I can't quite get out of here. I then might think of 3070, and that leads me to thinking of how about trying 31, and 2 cubed is 8, 3 squared is 9, 8 nines are 72. So one factor can be 72, the other factor can be 31. That will give us this, because this is the prime factorization of this number. And indeed, if we add the two, 31 plus 72 is 103. So by a bit of trial and error, we found the solution. The smaller root is 31, the larger root is 72. The second method is simply to use the formula for the roots of a quadratic equation. Precisely, ax squared plus bx plus c equals to 0 implies that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In our case, a is 1, b is negative 103, and c is 2232. Substituting these values into the formula here tells us that x is equal to this expression here. Using a calculator, we evaluate this square root to find its 41. So the roots are 103 plus 41 divided by 2, which gives us 72, and 103 minus 41 divided by 2, which gives us 31. We found these on the previous page simply by trial and error, assuming that they were rational numbers to begin with.